Thank you for joining us. My name is Frank Schirmeister. I'm Executive Director at Synopsys over in the Systems team. And I'm here joined by two partners of ours, Sanjoy Maithi from AMI and Marc Meunier from ARM. And we'll chat a little bit here at the Chiplet Summit, where you can see it is very busy, about how you get AI and HPC systems from the conception all the way to software-ready systems. So you need obviously IP, tools, software, IP subsystems, so we'll talk a little bit about that. Chiplet Summit is great. We have lots of interesting discussions already during the last couple of days here, and talking about how to scale to 1,000 chiplets, talking about the market dynamics with the very big players, how to make it accessible with an open ecosystem. So, Marc, why don't you tell us a little bit more about the market dynamics from ARM's perspective and how the ARM CSS and the market really drives all that from your perspective?
Sounds good, Frank. Well, I think we can't be talking about chiplets without talking about AI and the changes that is driving in the development of solutions. AI is changing everything, right? And when you look at the composition of a system, tuning that system to get the best performance out of it is now more important than ever, because AI is pushing the limits of power consumption, pushing the limits of compute, the constraints on memory. Everything is being pushed to the limits, and it's forcing us to think about new ways of integrating, new ways of connecting to build these optimized systems. So when I look at the trends and I look at chiplets, I think there's a movement here taking place. It's going to unlock lots of potential. It opens the door to partners working together, being able to take the best of everybody's offerings, stitch it together into a system, and then unleashing something that is more powerful than anybody can do on their own.
Perfect. From a market perspective, Sanjoy, tell us a little bit more about your perspective on like the compute layering, how we get from like individual cores, individual PCs to racks and so forth, reliability and all that. Obviously from a software perspective, tell us a little bit more about the market dynamics there, please.
Absolutely. So I will follow Marc's comment about AI and the demands that we see in the marketplace right now. So before that, I would little bit talk about what we do at AMI. So we are I would say cloud and AI infrastructure solution provider in terms of firmware and software. They are very critical foundational elements to make a data center live or operational. So in that perspective, we have absolutely from the hardware level all the way to the data center level visibility software that we provide to our customers. So as Marc mentioned that AI is pushing the limit. So when we are talking about this limit, it's limit of power, it's limit of cooling abilities, limit of running optimized workloads. Everywhere we are reaching the limits. So if you think of the power limit, even we are able to buy power with CapEx, but the companies do not have enough power to power on all the racks all the time. So what we do is, we see the demand that how efficiently a system can be built, and that cannot be just afterthought. It has to start from the ground up, where the chiplet is the new technology that is coming in the future, which will solve this kind of problem, the limit problem, like a power limit problem, the thermal limit problem, and the efficiencies. So we are seeing the demand of critical firmware, which is running inside a chiplet, to making sure that chiplet is operational most effectively and efficiently. We are also providing platform firmware where the board is built or the server is built, where it can be orchestrated properly. And then we also have the higher level software, visibility software like data center level management software, where we provide the telemetries, provide the ability for the data center operator to take decisions, and all the things, the holistic way that we see.
So it's a full stack really,
Full
from a
stack,
software perspective, building on the hardware component. So ARM and Synopsys, we are basically on the hardware IP side. Synopsys, I'll also talk about the tools a little bit. So let's imagine our viewers, we're here in Silicon Valley, have a idea for the AI accelerator component, and they obviously need to connect to compute and so forth. So we want to chart the path on how to get from that idea to, let's assume they have the money, let's chart that idea from the fundamental hardware components, how those integrate, then scale, and are enabled by software as multiple chiplets. So Mark, why don't you start a little bit with the ARM CSS and what ARM has been able to achieve there?
Yeah, sounds good. Thanks, Frank. So I think that if we were to take an AI chiplet and a company that wants to pair that with a compute element, definitely a compute chiplet makes sense. Now, at the foundation of that chiplet, you would find IP, either cores, a mesh, all the elements required to pull together that compute chiplet. Now, what CSS offers is a optimized compute subsystem. That's what it stands for. It offers that optimized and pre-validated compute element. Now, the CSS does not form a chiplet on its own. We still need to pull in I/O IP. We need to look at the security architecture of that solution. So there's a bit of work to do to build that compute chiplet, but that's what an AI accelerator would see at the interface between its chiplet and the compute chiplet, right? It would see a compute chiplet with a certain interface, and that would be the intersection point from a hardware perspective.
Right, perfect. So adding a little bit the Synopsys perspective to that, you mentioned the I/O bit, so there's a discussion about these I/O components, the I/O chiplets that connect everything. At the first level, when you have the compute foundation with the CSS, you add things like our DDR, our PCI Express, and then on a chiplet you will bring in our UCI Express and so forth. So that's something which Synopsys offers. So you plug those together, they all are to spec, and we have kind of pre-integrated some of it. I'll talk about the tools here in a minute. But Sanjay, tell us a little bit about, like, once you have the hardware components integrated, what happens next from a software level, and how do you actually do that? I assume there are various platforms, various engines. You can do that on virtually real hardware later on the chip. Tell us a little bit more about the UEFI, BIOS, bring up, and all those aspects.
Absolutely. So actually our journey starts before the silicon. We see the silicon on a board. So our journey starts working with the silicon manufacturer or the vendor very early days, from the conceptual day. And we work together to make sure that the components within a silicon are pre-validated. So Mark mentioned about the CSS or the compute subsystem which ARM is providing. If we look back, the industry started, computer industry started with a vertically aligned business. And if we name IBM, Sun Microsystem, or Burroughs, or Cray, they are all vertically aligned hardware, software, operating system, everything. That was the beginning of the computer era. Then the PC came and changed everything, and this is now horizontally aligned business that we see, and that is basically tremendous scaling that is happening. So vertically aligned things cannot sustain the scalability as we are living in this AI world, right? So ARM is providing a very important things we call CSS or ARM compute subsystem, which is a base, which is a horizontal stack across the ecosystem. So this is the answer to the horizontally aligned business and scaling that ARM is taking a big step and providing the CSS. We, as a partner, we are working with ARM from day one when in the concept stage of CSS, and we make sure that the CSS in every step, locked step with ARM, we are providing the validation of that CSS, support for the CSS, when the CSS will be taken by somebody and creating a custom silicon. So it is pre-validated. So it makes a big, time to market advantage and robustness to the quality of the product
Right.
also.
Yeah. And it's optimized, right? So you're getting
It's
the
optimized.
highest performance,
100%.
already tuned element.
Yes.
That's the idea.
So it's a good moment to switch my hat from the Synopsys IP side to the Synopsys tools side.
Yes.
So virtual hat switch. The way we met originally, and ARM and Synopsys have been working together for a long, long time, over decades, to optimize the implementations of cores, later Big Little, Dynamic Q, and now the Neoverse and Xena subsystems. We do this in the hardware world by bringing together the different IP components, the CSS, the Synopsys, DDR, PCI, UCIe IP, putting this together in various platforms, right? So ARM has the technology called Fixed Virtual Platform, FVP. We extend this with our VDKs, those are virtual development kits, and those are all in the virtual world, so that's software running on software models. And then we have emulation and prototyping and simulation, bringing all those components together and bringing them up on ZeBu, for example, in emulation, to have this integration of Synopsys I/O interface IP with a compute core and make it available. So tell us a little bit more about our partnership where your team is really sitting next to ours on a platform that has the CSS and the IP integrated, and you bring up UEFI, BIOS and so forth. Tell us more about that.
Absolutely. This is a great question. So when the CSS is validated with the fixed virtual platform, the fun begins when we actually start making the the custom silicon. Because the custom silicon consists of CSS as the base and then various IP. And the chiplet is made by heterogeneous IP on a chiplet. So CSS plus DRAM controller, PCI, network, everything can come all together. Now, again, if we only considering the silicon industry so far, silicon industry was also vertically aligned because every vendor was providing their own way of making the CPU. Now this is a big and vast ecosystem that ARM, AMI, everybody and Synopsys, we are all playing together. These IPs are coming, and now after validating the CSS, we are working all, Synopsys, ARM and AMI all together so that we can validate all the IP before even tapping out of the silicon. And that is a massive time to market. We can even look at that, we can skip or eliminate the necessity of a silicon spin. It can be possible.
Yeah.
Right, and then going back to our entrepreneur who is trying to build their AI product, they basically have these pre-validated components. Tell us a little bit more about what's the right term, compliance, standardization. We talk about things like system ready, SBSA.
Right. Yeah, so ARM is quite familiar with standardizations and tools to allow our ecosystem to build systems that are compliant and that basically allow them to take an operating system off the shelf and run it on their solution, right? The key to ARM is ensuring that the customers are developing, our customers, are developing solutions that can work together so that the burden on software is minimized. So when we think about chiplets and we think about the development where really what's happening is we're pulling in all of these different solutions into the SoC, what would normally have come together at a PCB level, right? And that's really what's forcing us to pre-validate and bring up the systems before the items before the various elements are taped out. That's what's driving that need, and I think it's key for this industry to see more of the development taking place pre-silicon.
Right, and the way that then implements itself in our tools is we have these libraries that will check for things like system readiness.
That's right.
For the various application domains that they can be executed pre-silicon together with your software. Also then checking the compliance for system readiness as well, right?
Yes.
Yep.
Absolutely. So it's more complicated, more complex when we think of the holistic solution to a customer, right? So a silicon is not just, so we have a principle or philosophy that we use internally within AMI in our mind when we are talking about ecosystem partnership or ecosystem contribution. We say building the firmware or the solution together with ecosystem partner, secure it, scale it, and deliver it, and sustain it, right? So we are talking about here security of a chiplet and a custom silicon when the multiple chiplets are used. We are talking about RAS, which is a big subject. We are talking about scaling this entire solution. So when you put all together validated components, not just the CSS, but all the IPs and together and test under ZeBu and as a simulation platform, or sometimes it could be also validated with emulators or emulation platform, which Synopsys also has. And all together is extremely important for our end customer because that is robustness, because security cannot be afterthought.
Right.
You have to design with that.
Right, absolutely.
Yeah, security, everything, the reliability, RAS, you mentioned that.
Yes, exactly.
So the way I explain this, not only to our Silicon Valley entrepreneur, but my family sometimes is, it is a little bit like Lego, but it's a bit more complicated. And imagine getting the Lego Star Destroyer for Christmas and then having to assemble it without instructions. Not only do we give you instructions as partners, but we also have actually proven that these things work, right? So we have actually shown that the PCI Express DDR with the CSS boots UEFI BIOS from AMI, so the user can really focus on their differentiation on top of it. So that's a great time starter. Can you tell a little bit, Mark, about the time to market impact all of that has for that entrepreneur who would otherwise have to build the whole compute subsystem himself?
Yeah, and that's a good question, right? Because time to market is key. If you look at the evolving AI space, the demand is increasing, but there's also variability. The way that AI is processed is changing very quickly. So companies need to be adaptable, need to be able to change. I think chiplets help with that. But when you think about time to market, what I think is really important to understand is the investment you make in pre-silicon validation, the work you were describing where you're bringing up your operating system or your UEFI environment on your system that's being modeled, that all translates to a faster time to market. But it also gives you that flexibility to make changes before you tape out.
Exactly.
You can pull as much of that work early and then still be able to make a change.
Right.
And then tape out.
Well, so the way we have been talking about this here at the summit was you shift left, so you will shift left to things like our prototyping technologies, FPGA-based prototyping, where you bring up the PCI Express with the drivers and the software at what we call at-speed prototyping, so really, really fast in the tens to hundreds of megahertz range. You shift a little bit lefter to emulation, where you get the advantages of performance analysis, you get the advantages of power consumption. Power is a big topic here with chiplets. You bring up your software on top of that ZeBu emulation model, and then you shift even lefter, if that's a word, onto the virtual domains, FVP, VDKs for you to do software. So you have all these things happening before you actually commit to silicon, which has significant market impact. So perhaps to drive this home, we could obviously talk about this all day until they throw us out here tonight. How's the future look like from your perspective? What's kind of the next step here? There's obviously many partners involved on ARM side. We are only 3 of a really vast ecosystem getting the foundation straight here. How do you see this evolve over the next couple of years when it comes to AI acceleration, software development, so forth? What's kind of the next steps from your perspective? Perhaps talking with you, Sanjay.
Yeah, absolutely. So as I mentioned, right, we at AMI, we provide the most foundational and critical cloud and AI infrastructure components, software and firmware components. So we look at a way that we need to solve some problem in the industry. And Chiplet and ARM ATD, this partnership, the program is the most diverse set of users and set of partnership. It starts from the IP design companies like EDA, ARM, of course as a CSS partnership as a IP. Then we are the firmware partner. There is a ASIC design companies, they are also partner. And then there is a packaging company, they are also partner. And finally the foundry. Now we need to work with all these diverse partnership here because Chiplet brings also diverse and heterogeneous component within a package, starting from the, sophisticated node level chiplet or the wafer to the voltage regulators. So if you think of that way, everywhere there is a scope of innovation. And power thermal wall is a terminology that people want to push to the limit for their best business outcome. And we alone cannot do it. So this big, diverse, partnership and the companies should solve this together, where there are controllable and uncontrollable parameters to push the limit for the most effective way of running the chiplet. It could be voltage, it could be frequency, and it is a capacitance effectiveness and thermal flux of the chiplet. And if you think of all the diverse partners, one of them are solving each of this problem. But if we work together as a team, I think this is the future because AI will grow tremendously.
Absolutely.
Power and thermal is our biggest challenge in the future as a sustainability.
So Mark, from a subsystem provider, IP and everything, next steps from your perspective?
I can't agree more with the statements you were making, Sanjoy. I think we're seeing a power crunch. We're seeing a need for creative solutions to come together. We've already seen that a vertically integrated solution can serve a certain market need, but if we want to really take it to the next level, we need to unlock all the innovation that these companies here bring together. And that starts with standards, and then we need to pull in a validation framework that shifts left, allows us to work together in an environment that is flexible, and then a fast path to market from the time you tape out to the time you package to bring up your system.
Right, and from there, we all, like you said, very diverse. I also enjoy the partnership where you really have in the ecosystem many players solving these really enormous challenges together. And then for us, of course, as Synopsys, there's both the IP components that's complementing what ARM has on the compute side, bringing those together, and then the whole tool stack from architecture through simulation, verification, emulation, prototyping, even the digital implementation, which we didn't touch on, that's getting pretty far away from the software, but even there, things like safety, reliability, and so forth are very important. So I think it's a really great partnership, and with that, perhaps just saying thank you, Sanjoy.
Thank you
for being here, Mark.
Thank you. Thanks
for having us. It was a great discussion, and with that, have a great rest of the Chiplet Summit.
Thank you.
Thank you.
Yeah.